My name is Patricia Croskrey, and this is an overview of my capstone project entitled Implementing Reform Mathematics in the Guided Math Classroom. First, let me give you a little background. I am just finishing my 4th year as a math specialist for 2 elementary campuses in Fort Bend ISD. I have built the relationships, established sufficient credibility, and laid the groundwork with my principals and teachers to allow me to implement some much-needed change in the way we teach mathematics. I will explain what reform mathematics is and what the research says about it. Then I will talk briefly about the how and what of guided math and why it is such a good fit in the reform mathematics classroom. And finally, I will explain how I went about implementing this change on my 2 campuses. Most of us are all too familiar with the traditional mathematics classroom. Let's face it, this is the way most of us were taught mathematics, and it's the way the teachers who taught us were taught mathematics. In fact, according to the National Research Council's 2001 book, Adding It Up, mathematics education has changed very little in the last century. It is widely published that school systems are struggling to close achievement gaps. But in spite of the evidence that too many of our students struggle with mathematics, the traditional whole class instructional model continues to be what most students encounter in the classroom. The 1995 TIMSS videotape classroom study found that traditional classrooms tend to follow a teacher-led whole group instructional model where the teacher asks questions that can be answered with brief, often one-word responses, and the teacher acknowledges the responses as either right or wrong. Students typically are not asked to explain their thinking or how they arrived at an answer, nor are incorrect responses investigated. The teacher typically presents new material through telling or demonstrating a procedure, and then students are given paper and pencil assignments to complete independently and without sharing ideas. Through these assignments, students practice the procedures and processes that have been demonstrated by the teacher, with the teacher walking around the classroom monitoring for understanding, and then a homework assignment might be thrown in for good measure. Little, if any, conversation is encouraged or allowed between and among students to deepen or expand their knowledge and understanding of mathematical concepts. Only after students have mastered the procedures and skills might they be shown where and when they might use them in a real-world setting. At this point, they might be given a few word problems to apply a math process to. The reform classroom bears little resemblance, if any, to the traditional classroom. Actually, you could say that the reform math classroom is the exact opposite of the traditional math classroom. In Adding It Up, the National Research Council talks about the reform movement of the 1980s and 1990s. The reform movement pushed the emphasis in the math classroom toward the development of what was called mathematical power. This power involved reasoning, solving problems, connecting mathematical ideas, and communicating mathematics to others. Proponents of mathematics reform are calling for teachers to move away from the traditional transmission model to a framework that allows the learners and teachers to work together to solve problems, engage in inquiry, construct knowledge, and communicate mathematical thinking. NCTM, the National Research Council, and a substantial body of research supports this reform movement and the idea that mathematical concepts should be introduced and taught through problem solving. Skill and process would no longer be taught isolated from the context in which students would actually apply the mathematics. Instead, they would be taught, investigated, and applied in concert through rich and rigorous tasks. The philosophy of a guided math classroom is a nice complement to reform mathematics. The instructional methods and philosophies that will be highlighted in the upcoming slides are supported by research to be essential to an equitable classroom and can be easily and efficiently accommodated through small group instruction. A guided math model affords teachers the ability to effectively differentiate instruction that is more closely aligned to individual student needs, thereby improving cognitive growth. Teachers can create small, heterogeneous, or homogeneous groupings that are fluid and changeable. Clear and consistent learning expectations can be more regularly and clearly communicated to the student by the teacher, thereby increasing student and teacher efficacy. A small group setting helps establish a closer bond between teacher and student to student that also increases student efficacy and achievement. The structure of an elementary guided math classroom varies and is flexible, but in a 90-minute math block, it may include 5 to 7 minutes of calendar time, a 10 to 15-minute whole group lesson that may introduce or allow discussion of a mathematical concept, instruct students on a project or task, or teach students a new game that reinforces a math concept. Teachers may pull small groups for 20 to 30-minute sessions, maybe 2 to 4 times per week. These are heterogeneous or homogeneous groups of 4 to 6 students. Some students are seen daily in small group, and some may only be seen once or twice per week, depending on the student's needs. While the teacher is working with small groups, other students may be working in their own small groups on rich mathematical tasks, complete independent work or assessments, complete workstation tasks that spiral concepts, and give students an opportunity to strengthen procedural fluency. Or if the teacher is not pulling small groups, she may mingle among math groups working on tasks and use questioning to foster or deepen student thinking. 30 to 45 minutes may be devoted to students presenting and justifying task solutions. A 5 to 10-minute math huddle at the end of the day where teacher and students debrief, which allows the teacher to note and clear up misunderstandings or misconceptions. Information from this huddle can be used to direct the following day's whole group session. So while Reform Mathematics in a guided math classroom seems like a reasonable, efficient, and superior model to the traditional classroom, change is hard. Reform Mathematics asks teachers to change their mindset from a primary focus on procedural fluency, which is at the heart of most elementary classrooms, to a more intertwined curriculum that includes not only procedural fluency, but also conceptual understanding, the ability to formulate, represent, and solve mathematical problems in a real-world context that includes logical thought and justification, and the ability to communicate one's mathematical thinking. This is a paradigm shift for most teachers that will require sustained support, professional development, and coaching. With the 2012 adoption of the new TEKS and the implementation of the associated student assessment called STAR, students are required to be sophisticated problem solvers. They are no longer simply asked how many in all type of questions. Instead, they need to know what their possibilities are with a problem without having only to rely on a formulaic mechanical process to solve it. Students need to be able to make sense of what they are being asked in a contextual problem and persevere through to an end solution. Students were not being taught in the classroom the way we expected them to apply mathematics, nor the way they are being tested on the STAR tests. The majority of the teachers I work with taught a somewhat hybrid model of traditional and reform mathematics, leaning more toward the traditional. They taught students a math process, meaningless to many students because they didn't know how to apply it, and then students tried to apply the mechanics to word problems, but not necessarily problem solving. When students were presented with state testing, they were having a hard time keeping a multitude of processes straight and then problem solve all at the same time. As the first step in my action plan, I wrote an NCTM grant for staff development entitled Teaching Critical Thinking and Problem Solving in a Guided Math Setting, and my grant was approved. The $4,000 grant was used to fund a customized guided math workshop that was presented by Dr. Barbara Blanke. Dr. Blanke provided a full-day in-service on August 19, 2013, to teach the benefits and how-to of problem solving in a guided math setting. Dr. Blanke wrote and provided a manual implementing guided math, practical strategies to differentiate your math instruction using small group work, problem solving, and math learning centers, which were distributed to teachers for their use during the in-service and then to keep and use as a reference throughout the upcoming school year. Teachers were also provided the book Introduction to Problem Solving by Susan O'Connell for grades K2 and 3-5, which was used as the basis and focus for teaching problem solving in each mathematical strand. The workshop provided teachers with a procedural understanding of the components of guided math. Throughout the day, teachers worked on the first steps to implementing this model in their classrooms, which included how to plan, conduct, and manage differentiated small group sessions and math learning centers to scaffold the needs of students with varying math abilities. Teachers also looked at the practice of questioning to facilitate a deeper understanding of the mathematics and problem solving as the primary format to learning mathematics. A few months after the guided math workshop, I developed and provided a half-day in-service to teachers on differentiating small group instruction. 3 third-grade teachers modeled what they had learned and been practicing in their classrooms with differentiated small group lessons. The concept of inferencing in mathematics was demonstrated at 3 different levels that included a complex problem, an on-level problem, and a more simplistic problem. Teachers modeled for the whole group what small group differentiated instruction looked and sounded like at each level, and then how to scaffold students to the next level and extend beyond. The audience teachers then broke into small groups and practiced differentiating other lessons and presented their ideas to the whole group. At the end of February, I presented 5 productive talk moves from the book Classroom Discussions Using Math Talk to Help Students Learn, and practiced this type of questioning with teachers at a 1-hour in-service. A 4x6 laminated card with the 5 talk moves, revoicing, restating, agree, disagree, adding on, and wait time, each with a short description, was provided to teachers for easy reference and use in their classrooms. Instructional coaching and modeling talk moves in the classrooms were also provided to teachers as a follow-up for implementation. In addition to the specific professional development sessions and instructional coaching, I facilitated monthly professional learning community meetings, or PLCs, which afforded teachers the opportunity to share best guided math practices, differentiated instruction ideas, experiences with the use of questioning, and problem-solving ideas and resources. Although a few teachers resisted the implementation of guided math in their classrooms, the majority of teachers from both of my campuses have implemented guided math in varying degrees. The teachers who successfully implemented the guided math model have seen a rise in this year's benchmark scores over previous year's scores. These teachers are able to speak knowledgeably about the specific struggles of their students and collaborate with other teachers and me, their instructional coach, on how to further differentiate their instruction to best meet the students' needs and boost their math ability. Mathematical discourse and the use of questioning is evident in their classrooms, and the students' ability to use reasoning and proof to support or defend a mathematical position has seen a dramatic rise. As a result of these elements, students' ability to successfully problem solve has also substantially increased. The teachers who were resistant to implementing guided math, novice and veteran teachers alike, found it difficult to give up a mode of instruction that is comfortable and routine for them. At the very least, most of these teachers have implemented math workstations to spiral the curriculum and reinforce concepts, and have made the first steps toward using talk moves to begin math discourse in their instruction. Instructional coaching, PLCs, and planned upcoming professional development sessions will be aimed at supporting these teachers to make the guided math model a reality in their classrooms.